To wrap up our discussion of disruptive testing, I would like to present our new tool by Exactpro. Yes, and now let's have a closer look. What we do in Exactpro is build software to test software. And today, for the first time ever, we will talk about our new tool, a ClearTH extension called Woodpecker. ClearTH is an Exactpro test harness able to simultaneously execute multiple end-to-end test scenarios in batches. ClearTH easily detects abnormal behavior in the system under test and effectively predicts any potential issues. It offers many built-in actions to cover the majority of activities in post-trade systems. ClearTH has got several important features, including multiple protocols, among which are Swift, Fix, market data, etc., concurrent automated test execution, multiple data scenarios, integrated scheduler, and simulators. And to enhance our approach to software testing, we've designed Woodpecker, a tool which can be integrated into ClearTH and its automated scenarios. Like ClearTH, it is aimed at testing post-trade systems, and as its improvement, it combines functional and non-functional approaches. So let's see how it works. The core idea of Woodpecker is to act as a platform for daemons. Daemons are programmable modules which can be relatively simple and provide a higher performance for load testing, or vice versa, they can be more complex to cover diverse testing scenarios based on different rules and logical conditions. The daemons can work independently as well as in groups. As for Woodpecker's internal structure, its core is written in Java, but the user can configure it via XML configuration file. And also, what can we customize? The user can customize the input sources, the input data. We can take it either from the file, or we can get it dynamically from the system under test itself via SQL queries. The tool can interact with the client system via diverse messaging protocols, via the front end using an API or through a database. While working, Woodpecker monitors the system and is capable of making self-corrections to the generated flow based on what it sees. One of the advantages of the tool is that once configured, it can be quickly and easily transported and deployed to other test environments. Woodpecker's main task is to simulate a workflow with a system under test based on the data extracted from the system itself. So a little bit of video here. A daemon sends a big load of messages based on its configuration file, which describes the logic for its behavior. As a platform, Woodpecker allows a number of daemons to perform at the same time, and thus a single tool can create parallel flows of different data types through a number of connections. Woodpecker is operated through a GUI which shows the working status of each daemon and allows to change the parameters of its configuration on the fly. All the data we can see here is generated based on interaction between Woodpecker and the system under test. It consumes feedback and adjusts its generated data flow to the client system's behavior. The tool has a visualization tab where the progress and its quantitative characteristics can be seen. We can launch any number of daemons and their configurations at the same time, changing their parameters so that we can see the resulting changes at once, visualized in a form of a dynamic graph. So pretty dynamically. Woodpecker is a perfect tool for the disruptive testing approach. Highly customizable, portable, it allows to flood the system under test with an algorithmically generated data flow, thus providing a perfect coverage of possible testing scenarios created without humans. As a result, Woodpecker helps to approach a system under test from diverse angles and uncover defects which potentially lie at the confluence of functional and non-functional areas. And now we have a black Woodpecker to look for black swan events in your systems. So, thank you.